Welcome to lesson 6.7. Now before I dive into the lesson in your notes, I wanted to start with a little review. At this point, we understand that a derivative is a slope. At its core, that is what a derivative means. It means slope. Whereas an integral at its core means area under a curve. So, for example, let's create a curve here. Let's say this curve, actually I'm going to make these a little wider. Let's do this. And let's say our curve looks like something like this. Okay, so let's say this is our curve. And I want to find the integral from 0 to 4 of this curve. So we know at this point that this means I want to find all of this area. That's what that integral means. I want to find the area under this curve. Now, we've learned a lot of different ways to find that using the fundamental theorem of calculus, using graphing. Today's whole lesson is about one big word: approximating. That's this lesson and next lesson. It is about what if I have a curve that I can't actually find the integral of. We don't have rules to integrate it. Well, we do have some techniques to approximate this area, but that keyword is approximate. It is not actually finding the area, it's approximating the area. And the first technique we're going to learn about is called a Riemann sum, which is a fancy word for let's make some rectangles to fill this area. Now, there are three types of Riemann sums. You have a left Riemann sum, a midpoint Riemann sum, and a right Riemann sum. And each of these are different. So I want to go over, with the curve that I have here, an example of how all of these are different. So let me color code them so you can see. We'll do left, red, let's do midpoint, green, and right, blue. Okay, so a left Riemann sum means I'm going to make rectangles from the left point. So here's my left end point. So I'm going to make a rectangle from that left end point. Here's the next section. There's my left end point. So I'm going to make a rectangle from that left end point. Here's the next section. There's my left end point. So I'm going to make a rectangle from that left end point. And then here's my last section. There's my left end point. So I'm going to make a rectangle for this left end point. That would be our left Riemann sum, where we would just find the area of all of these rectangles and add them together. So 2 times 1 plus rectangle 4 times 1 plus this one is 3 times 1 plus this last one is 7 times 1. And here's where that big thing comes in, that approximating. You can tell that these rectangles are not actually that area under the curve, but it is a fairly good approximation. It's just approximating. Now, here's the other cool part. You guys love this. You don't need to simplify. You can leave it like that. Okay, let's do a right Riemann sum next. This is where you use the right-hand values. So here's my first section. This is the right-hand value. So this would be my first rectangle. Here's my next section. There's my right-hand value. So this would be my next rectangle. Here's my next section. Here's my right-hand value. So this would be your next rectangle. And here's my last section. There's my right-hand value. So that is your last rectangle. So to find that area, this one is 4 times 1 plus 3 times 1 plus 7 times 1 plus 0 times 1. And that would be our right Riemann sum. Okay, last one, a midpoint Riemann sum. A midpoint uses the point in between your sections, the exact middle. So for this one, the exact middle is at 1/2, so I'd come up here to 1/2 and approximate where that lies. That looks to be about 3.5, we'll say. Now, here's my next section. There's my middle. So let's go up to the graph, approximate. Still looks like pretty close to 3.5. So we'll approximate it. Okay, here's the midpoint of our next section, 2.5. Go up half to the graph. There's our rectangle. And I'm going to say that's about at 5. And last one, there's my midpoint, go up, that's where it goes, so that one is also about at 5. So my midpoint is going to be 3.5 times 1 for this first rectangle, plus 3.5 times 1 for that second rectangle, plus 5 times 1 for the third rectangle, and 5 times 1 for the last rectangle. And those are our 3 different kinds of Riemann sums. So in the next video, we'll actually go through your lesson and do the examples in your lesson using what we just learned in this video.